Hi, thank you all for being here and welcome to our 35th annual NEARC conference. My name is Emily Wilson and I'm the current chair of the NEARC Board of Directors. And I want to start off by acknowledging the difficulty and the struggle that we have all had this year for many different reasons with sickness or finances or trying to balance teaching and work and lots of other things. So I want to thank everybody for being here amongst all of that. I know I look forward to NEARC to learn a lot of new things and keep up with the technology, but what I really look forward to is seeing old friends and meeting new friends. So given all that is going on, I'm especially glad that we can all be here together for a few days, even if it's in a totally new way. So I would like to welcome everybody and we're glad you are here. I want to welcome our first time attendees, whether it's because you are new to the field, or maybe you can actually attend NEARC for the first time because you do not have to travel or the expense is lower. So welcome everybody, especially if it's your first time. We have a really great distribution of folks here in the conference today from all different sectors. And we have a great distribution of people from across the country. So this is one benefit of being virtual is that we have been able to expand our reach. And here we are across our usual region. So what is NEARC? NEARC is a community, it's a user group of people. NEARC is dedicated to helping GIS users improve their skills and also is working to build and grow a vibrant community of users. NEARC is an independent nonprofit organization that is led by a rotating board of directors and host committees. We are all volunteers and always looking for new help. NEARC is a 3-day fall conference. That's what we're kicking off here, and also a 1-day spring conference. The fall conference rotates around the New England states and New York. That's our area. And the spring conference also has recently begun rotating kind of in the central part of our region. We also have an email listserv that I encourage you to join if you're not a part of. We send information about the events, but it's also a good place to learn about new things, job opportunities. People ask questions and get answers almost immediately. So it's a great community. So I want to thank the NEARC Board of Directors. They are all listed here. This has been quite a year to be on the board and has been much more work. We've had to negotiate contracts, change things at the last minute. Putting on a virtual conference is a lot of work, and I want to especially thank all of these folks on the board who really became host committee members as well. And I do want to mention Shane Bratt, who stepped in this year when another board member took a different job and had to step down. So thanks to Shane for stepping in unexpectedly. So NEARC is about you. By attending this conference, you are a member. Welcome and congratulations. To learn about NEARC and how it works, come to the business meeting today at 3:15. Actually come anyways. Because you're a member, we need member input. We vote on different things and we hope you can attend. There are 3 open board seats this year. So we're looking for nominations for new board members. So what that means is you need to have an interest and someone needs to nominate you. So you have a few hours today to get that in order if you're interested in becoming a member of the board. We will also review last year's events and we will talk about our upcoming events in the next few years. And sorry, but usually we give out free drink tickets when we're all together, but you know, boo COVID. So NEARC does depend on user participation in terms of coming to the business meeting and the board, as well as doing presentations and joining in our community, all of the different discussions we will have here. So please participate. So welcome to virtual NEARC. We are not at one of these lovely locations this year. Instead, we are properly socially distanced all across the country, and we are going to make the best of it. So thank you for joining from your offices, your living rooms, your basements, and wherever else you might be today. So I want to go over a few tips that we have learned about Whova the past few days to try to make things as smooth as possible. It is new to everybody and there is a learning curve, but I know we will all figure it out. This conference is much more than just a day-long Zoom. There are a lot of opportunities to meet up and communicate and network. When you do go to a meetup the first time, you'll be prompted to install this Jitsi meeting add-on, I guess it is, for Chrome, so don't be surprised by that. And if you are looking for meetups, you can find them under the community tab, and then it says meetups in virtual meets. So, I want to make sure everybody knows where to find those. All of our user sessions also have a question and discussion period at the end That's to encourage discussion and communication. So please turn your cameras on and partake in those discussions. So it's kind of, so we're like sitting around in a conference room after a presentation had end. So aside from the plenaries like this one, all of the sessions will be Zoom meetings. And we did that on purpose so we can see each other, we can be able to see who is there. And when we ask questions, we can actually talk as opposed to just texting in questions. So I think this will benefit our conference tremendously, but it also comes with a little bit of a risk. So please be sure to keep yourself muted when you are not talking. We do recommend using Chrome. That's the Whova browser. So if you're not in Chrome now, consider trying that out. Also, if you can't find the Zoom for a session, look for this breakout button. All of the sessions are breakout Zoom sessions, so it looks like that. And I also want to mention that the chat and the question and A are not in Zoom. They are disabled. They are in Whova. And it's a little bit clunky because you do have to go between two windows. But the benefit of that is that the chat and the question and answer can begin before the session and continue afterwards, as opposed to it just disappearing with the Zoom. So take a look at that. Within Whova, find the agenda item, and then you'll see next to it is the session, question and A, and chat. So keep an eye out for that. You also might want to try out the app. It's certainly not required, but there are some things on the app that do not exist in the web browser, including the leaderboard for Whova points. If you do run into problems and need help, one thing is to participate in the NEARC 101, which just happened and will happen again tomorrow morning. And that NEARC 101 turns into a help desk until 10:15. You can also look for the community area within Whova, and there's an option to ask organizers anything. And the NEARC Whova homepage has a link to the intro video that Shane created that's excellent. It's 5 minutes and definitely worth your time. Ways to help, contact help at Delaney Management, their email and phone number, as well as information about the different competitions that are going on. So some of our conference highlights. We have a great lineup of user presentations and sessions. We have some vendor booths all set up, including the scavenger hunt to go visit them, and a lot of different posters. So just as another tip, when you go to exhibitors on the left side in Whova, there is this drop-down menu here to sort those. So you can look at just exhibitors or just posters and some other categories within there. We also have a great lineup of Esri technical sessions and presenters. The Esri Wednesday question and answer, which is kind of like a collaboration center, is happening. We have some outstanding keynote speakers that we are about to hear a few of them here in a couple minutes. We have Mappy hours set up, which are bound to be a lot of fun. So if you're drinking from your NEARC mug, make sure you have your pint glasses lined up there ready for later. We'll have an award session on Tuesday where we will award the poster prize winners, the scavenger hunt. We are also having a competition for Whova points. We will announce the new board members and also talk about the Esri SAG award winners. There is a poster and vendor social, so check that out and visit the different poster authors as well as our vendors. We'll have a fun time with GeoJeopardy tomorrow. I can't wait for that. And of course, the business meeting, which I already mentioned. Okay, so some very big thank yous. As I mentioned, the board really stepped up this year. We put a lot of time in, thanks to all board members. Our host committee was initially created to put on a nice conference in New Hampshire, and many of them stayed on, so I appreciate them, their contributions. Esri has been a huge help all the way through, especially Paul Rooney and Mary Young, who have met with us many times, shared lessons they've learned from the UC, and helped make the conference as best as possible. And of course, Delaney Meeting and Event Management and Leslie Pelch, you probably know by the sheer number of emails you've received from her, how much hard work this is. There are so many details and we are all learning as we go. So I want to send a huge shout out to Leslie and her team for putting all of this together. And finally, we could not have this conference without our sponsors and our exhibitors. Thank you to all of you for contributing content as well as financial support for the conference. We're very happy to have you here. So with that, I'm going to turn the stage over to Carl Nyland.
Thank you, Emily. Can you hear me clearly? Very good. Good morning, everybody. I'm Carl Nyland, not Paul Bruni, as the agenda might have indicated, from Esri's Northeast Regional Office. And I am very happy to be here greeting you this morning. I want to extend a note of thanks to Emily and the whole NEARC board for once again assembling a stellar fall conference, one we've become used to. I think this year in particular, you all deserve a special note of appreciation for adapting the conference to our current conditions and so seamlessly transitioning it to a virtual conference. I think we can all acknowledge that we'll miss the camaraderie of a traditional fall NEARC, but we can look forward to a day, we hope, in the not too distant future when we'll be able to gather in person again. And in the meantime, we'll be able to enjoy the opportunities that this year's conference does present for us to listen and to learn, to share, and maybe most importantly, reacquaint ourselves with friends and colleagues. It is probably an understatement of the obvious to say that this year has been unusual. All of us have had to adapt personal and professional lives to new ways of living and learning and communicating and conducting business. But despite these challenges, it's worth noting that in this year, I think as much as any, it's really been inspiring to witness the work of the GIS community, the work of, frankly, most of you here attending today in the NEARC community, pitching in your expertise, your energy, supporting local, national, sometimes global efforts to confront chiefly COVID-19, but also many of the other social, economic, political, environmental challenges we face. It's no, I think, chance occurrence that GIS plays such a prominent role in these efforts. And it's a testimony, in part, of course, to the power of geographic science and the growing awareness of that, but also to the talents of all of you, the individuals who apply that science in your chosen fields of profession. Today and over the course of the next 3 days, of course, we'll have an opportunity to be reminded of this power and those talents. And I think I can speak for everyone in saying we're looking forward to every opportunity we have to learn. No NEARC would probably be complete without some words from Jack Dangerman. Jack, to most of us, Esri's founder and president to some. And Jack has prepared a few words that he'd like to share and welcome. So Jack. Well, thank you, Jack. Powerful charge for the week for all of us. And with that, we wanted to get things started with the first general session of the conference. And it's a pleasure for me to be able to introduce our first panel. It was noted in the agenda, as you might have seen, that it's appropriate, since the COVID-19 pandemic is the reason this conference is being held virtual, that we would start the general session off with a panel talking about how GIS has been utilized to affect, inform, manage the pandemic locally and globally. And so we have a really exciting panel this morning to talk about these and share some of their work with you. It'll be moderated by my colleague, Este Garrity. Este, as you may know, is our Chief Medical Officer and leads Esri's worldwide health and human services practice. And she will introduce the rest of the panel for you. So without further ado, Este, the stage is yours.
Thank you, Carl. I really appreciate that. Let me get my screen shared. Okay, well, good morning, everyone. It's pretty early over here on the West Coast, but I'm ready to go, and I want to welcome you to this keynote presentation panel. As Carl said, my name is Este Garrity, and I am the Chief Medical Officer at Esri, and I will be your moderator for this kickoff session and the kickoff speaker for this session. So our session today is about how spatial data has absolutely, certainly taken center stage with COVID-19 over the last 10 months. I'm guessing you probably noticed that. But today you're going to hear the story of how that happened and what it means for GIS and for health GIS going forward. So my fellow storytellers today are Aaron Katz from Johns Hopkins University, Sean Breyer, one of my colleagues from Esri, and Tim Turway from the state of Vermont. So I will ask you to please take some time to review their full bios and profiles on the Whova app. Now, before we get started in earnest, I wanted to encourage you to submit your questions. We'd really love to take your questions, and you can submit them anytime you want through the Q&A or the chat functions for this session on the Whova app. So as was mentioned earlier, if you heard it, the chat feature in this Zoom meeting has been disabled. So you really need to use the app to get your questions answered. And I'm going to be keeping an eye on those questions as they come in. And I will then later at the end of the 4 talks, direct your questions to our speakers. We'll have a conversation about them. And you are also, by the way, welcome to reach out to any of us as speakers individually through the app, if you prefer to do it that way. And of course, as also mentioned before, I will ask you all to keep yourselves muted during the presentations and keep your cameras off. And maybe the technology has already solved that for us. But let's just go ahead and get started. I think what we're all probably realizing more than ever before is how interconnected our global populations are. For my part, I'm feeling this sense of unity with people all over the world, because no matter who we are or where we live, we are all faced with this common challenge of addressing the coronavirus pandemic. In this effort, as I said a moment ago, spatial data and GIS have taken center stage. And as a group, this panel is going to share that story of the data and the dashboard that has changed the world. So we'll walk through the subsequent information revolution that's happened and the expansion of spatial data and discuss the implications of this for the future. So let's start here. Where better with a familiar site. Now, I personally first came into contact with this dashboard very early on January 23rd after seeing the tweet that came from the JHU team, and showed it to my whole team at Esri. We checked it out, and we were all really impressed by its clarity of message. It was very well done. And I guess we weren't the only ones who thought that, because the dashboard had tremendous uptake. It quickly became a backdrop for operations centers around the world, from the US Health and Human Services Secretary's Operations Center to emergency response meetings that were happening in Germany. We saw it for coronavirus briefings in Italy, and it's even showing right in the background there in Ireland, among so many other different places. Now, the influence of the dashboard really broadened when respected journalists started writing about it. And the coverage was broad, but some notable examples included the New York Times, BBC World News, and actually our own Esri website used it on a landing page that was, and still is, devoted to COVID-19 resources. Now, the story of this dashboard was featured on National Public Radio, in Science, very prestigious, in the Nature Index, in the Wall Street Journal, and many other publications. And actually, I was even quite honored to be invited to talk about the dashboard and mapping of coronavirus on CNBC News. Now, the dashboard went viral very quickly. Jack mentioned some of that. This graphic is showing you the first 3 months of feature requests starting from that dashboard's introduction. So take a moment and look very closely at the scale on the vertical axis. Each division is actually 500 million feature requests. So at an early peak toward the end of March, the dashboard was being requested 4.5 billion times per day. Now, compare that to the current world population, and I think you're starting to get a real sense of how remarkable these numbers are. Now, beyond alerting the world to the developing crisis, the JHU dashboard inspired others across the globe to configure their own dashboards. We began to see a number of lookalike apps that included some combination of black backgrounds, graduated red symbols for cases, and dark gray base maps. It seemed that health organizations were really starting to recognize how easy it is to configure their own visualizations and then localize them for the needs of their particular populations. And all of this work was made possible by the fact that the JHU team decided from the very beginning to share their data with the world. So if I may, let me summarize some of what I think are the key outcomes from the Johns Hopkins University COVID-19 dashboard. First, it did truly broadly demonstrate the value of GIS for health applications to a global audience. And as I mentioned, the fact that the JHU team put data sharing first was a huge enabler that helped all kinds of organizations, especially health organizations, to visualize, analyze, plan, and make better decisions in their COVID-19 response. Not only that, but the JHU data, by comparison, exposed gaps in our public health systems in collecting and sharing data with the public, and it exposed some level of a lack of interoperable systems that would be able to provide a cogent national picture right up front. And so what this did was it inspired a lot of really good questions about who should be an authoritative source of data in a situation like this. And these kinds of questions aren't meant to be critical to any organization, but they're important points of discussion that really have the potential to enhance public-private partnering and improve our capabilities for the next crisis. And finally, the JHU dashboard, because of its regular updating, built expectations among all of us for real-time and near real-time data. Now, many of you are probably not in health, but let me assure you, we've never really had that before with health data. It's a completely new expectation. And I have a feeling that this is actually going to help push technology systems forward in very desirable ways. And with that, I hope that you have a better early sense of why this dashboard is such a big deal. And now it's my pleasure to hand it over to Erin to share more details about creating the most viral map-based application in the history of the world. Erin?
Thank you, Essie. And I guess no pressure, but thank you for the opportunity to talk with everybody today. My name is Aaron Katz. I'm with the Johns Hopkins University Applied Physics Laboratory. I lead the large scale analytic systems group at APL, which we're part of the asymmetric operations sector. And I've done a lot of work in the
I
Yes.
just want to very briefly interrupt to say that you're in presenter mode rather than presentation mode.
Oh, gotcha. Thank you. Let's see if this works. Oh, it keeps.
There you go. Perfect.
Is that present? Okay. Thank you. Sorry, I seem to always do that in Zoom. So I want to give you a little bit, as Esty was saying, I want to give you a little bit of the nuts and bolts behind the data collection efforts for the dashboard, which either will be interesting to you, or if not, I've had a lot of coffee this morning, so I'll go quickly. So either way, I hope to make you happy. That said, going back to the beginning of the dashboard effort, Lauren Gardner and Dr. Lauren Gardner at the Centers for System Science and Engineering in the Whiting School at Johns Hopkins, along with Frank Dong, met early in the outbreak on the 21st, and just had an interest in putting together something. They both live in a modeling group in the Whiting School, and they do infectious disease modeling, and said, hey, you know, we need to start collecting this data, and let's come up with a way to sort of visualize this and share this visualization so that people have an understanding. And we can also, you know, do quality assurance as they're collecting the data. And so that became the first generation of the initial dashboard that went out on the 22nd. What was, I don't think anybody was prepared for the impact. So from a few thousand hits on the 22nd, the dashboard went to 10 million hits per day. By the end of that week, it just went viral. And it was towards the end of that week that I got the call from Dr. Gardner out at APL, because there was an understanding that the model that they had, the model that was in place for sort of doing open data collection and curation just wasn't going to scale. Dr. Gardner's team was doing manual data collection from a host of authoritative as well as crowdsourced sites. So they were pulling data from the WHO and the Chinese Centers for Disease Control and Prevention, as well as crowdsourced data from Chinese social network aggregators like DXY. They were getting, you know, tips from email, and they had a public Google sheet that they were getting comments from. All of this was stitched together manually and then pushed out to a Google sheet for public data sharing, and then out to the dashboard. So it was fully manual, and there was an understanding that just wasn't going to scale. So again, in that first week, a call went out across the university, and to Esri to say, you know, we need to do something different. I've done a lot of work in the past in sort of open data operations, which is why I got the call. And we partnered with CSSE along with our peers at the Sheridan Libraries and Sean Breyer's team out at Esri Living Atlas. And what we came up with was a structure. We realized manual was not going to work. We needed to come up with an automated infrastructure. But how do you do that in a way where you have clean breaks? And so we had this picture, you know, sort of a first level operational view, where we said, look, we're going to have this thing, we'll call it the COVID data pipeline, that's just going to come out, eat all the data in the world, format it, and we're going to push it someplace open, because, you know, as we're in the middle of a pandemic, you know, people have a right to know what's going on. And if you want people to make informed decisions, you're going to have to provide the data at a spatial and temporal resolution that allows them to understand their world and take appropriate action. And so we felt that very strongly. So we decided that the only responsible thing to do was to make this data public. So that's why the breakpoint in here is we push all of the data publicly to GitHub, which makes it available to a certain subset of public consumers. But as Sean will talk to you more about in the talk after mine, we also pushed it into this infrastructure that he and his colleagues at Living Atlas created, that then enabled this entire GIS infrastructure and made that data available, as well as fed the dashboard. So that first initial architecture met the needs of that OV1, but caused none of us to really sleep for a few months. It was essentially, you could think of it as a singly threaded automated pipeline. So everything had to work from collection through creation of the product. And in this serial pipeline, we would then share the data and produce the automated updates. One of the challenges there was really that errors would have to be discovered at the end of the pipeline run. So this created a lot of back and forth. I mean, the fortunate thing was, you know, having GitHub in the middle, we had version control baked in. So as we had to make changes, we could just do updates, and the infrastructure that that Sean built was smart enough to say, oh, well, this is, you know, there's a change here, and it would pick it up, and those updates would propagate. But like I said, it was a little bit nerve wracking. So we made some improvements, especially as you know, Esty was saying, there's just this proliferation of use, almost unexpected proliferation of use, which really led to expanding demands. So the challenge here was, anytime we ran into issues with data, anytime there were errors in what got pushed, if we dropped cases for some reason because somebody upstream either stopped reporting them or changed the way that they were reporting them, I mean, we would get calls. The media office at the university would get calls within minutes, and then that would come to us, and we would scramble, and we would fix things. We were happy because we wanted to, again, for the purposes of making this data publicly available to help you know, the world's understanding in this crisis. We were committed to making this work, but there were a lot of thorny issues we had to deal with, including, for example, you know, just misunderstanding, right? Like, we had to deal with, you know, I'm sure, since this is a talk to a GIS community, I'm sure you understand the challenges of naming conventions and you know, different standards about, you know, who's where and what things are a part of. That led to a lot of angst, and who was reporting what data for what location, and how do you disaggregate that so you're not double counting cases. We've had to do a lot of work along the way. And really, you know, so the question, I was talking with somebody recently, and they said, well, you're just getting data. Like, why is that hard? And I think Esty hit on this in the talk before mine, right? It's hard because the standards aren't there. I mean, there wasn't a clear guideline that said, you know, you will share data in a pandemic exactly this way to, you know, to your users and via these mechanisms, right? And that's not anybody's fault, right? I mean, Tim, who'll talk a little bit, I think after Sean, right? The public health community is doing amazing work to get information and try to make it, you know, try to make it public. But everybody here is learning as we go, right? We're just one order removed from that, because we have to, as people upstream are learning, we have to learn what they're learning and detect their changes and then accommodate their changes. So that includes challenges around things like retrospective reporting and data structures and you know, dealing with machine learnable data. There's also a lot of issues with discrepancies, and this is particularly in the U.S. We have a highly decentralized public health system, and so what you'll find is local public health entities will report different data than state public health entities will, and how that propagates up to federal agencies is often voluntary in that data transfer. So there's challenges there. These same sort of ambiguities lead to differences in understanding data between locations. So there's CDC guidance on how to count, you know, confirmed cases versus probable cases, but that gets interpreted differently by different locations. Another challenge for us is just, you know, and I again, this being a GIS community, I know you understand this, like snapping a chalk line at any point during the day is pretty difficult, because as most people agree at this point, except for a few crazy people on the internet, we live on a globe, right? So it's always noon somewhere. So snapping that chalk line has been a challenge. So to deal with some of these challenges, we generated this sort of refined architecture that included a lot of automation for detecting errors, for Sean's team was gracious in helping us set up a parallel testing pipeline so that we have a public dashboard, but then we have a replicated infrastructure so we can push on a different time scale and see what's happening on the map and correct any errors that might be happening. And we really have this an automated anomaly detection, which is really key, that sort of holds back things that might be of question, data points that might be questionable, and it launches this whole human machine teaming process that allows us to do that correction. But there's still a lot of dependency, and it was a lot of dependency in that first architecture because of that serial nature, which got stressed even more as this partnership expanded to include the Coronavirus Resource Center, which was another effort launched by the university in late March for doing understanding around things like policy and testing. So the challenge for me, I think, as a data scientist, for my day job, is really, how do you build two planes in flight simultaneously? It's hard enough to build one plane in flight, but what we had to do was build two of these planes in flight because we knew what the challenges were. That first generation architecture was never intended to be a permanent solution. It really required 24-hour, 24/7 monitoring and maintenance. We're all talking now about Thanksgiving and who's covering what part of the day. But we had to pay, the challenge for us was, in a typical software development environment, there's a cycle, right? You do requirements gathering and development and testing before you go to production. Our issue was we had to be in production on day one, and then develop as we go. So to make that transition from what we were doing to what we needed to do successful, there were just 4 of us that agreed that our life was going to be terrible for what turned out to be 6 months that it took to buy this combined development team time to develop the ultimate infrastructure that we needed. And all of that was possible because as we were going, we had support from experts at CSSE and the Coronavirus Resource Center, and out with Sean and Paul out at Esri Living Atlas. Which got us to where we are today. So we went live with this in August. This is sort of our second generation architecture. The key being, this is more what we would have designed from the beginning, right? It's a fully parallelized architecture that splits out the ETL processes so that you can capture raw data, because this data is essentially ephemeral, while we're also doing this transformation process into a production data store that then allows us to run multiple fusion engines to do analytics, as well as public generation of product. The other thing that's really interesting here is it's allowed us to expand out the number of sources that we collect. So publicly we provide, if you take, I don't know, the state of Vermont, right? Like publicly we're taking data from the state of Vermont and we're publishing that data directly from the state. On the back end, we're collecting data from, I'm trying to think, Vermont, roughly 5 different sources about the state of Vermont, including this authoritative data source that we're publishing. But that allows us to enhance the anomaly detection capability, because if we start to see sources that are in disagreement on the back end, that becomes a part of the alerting infrastructure that lets us say, hey, something's going on here. We need to go figure out. So, which kind of brings us to where we are today. I think the thing that I'm happiest about here is that we've curated this open data set that's like hopefully helped people in the middle of this crisis make some solid decisions, and more importantly, has helped this community meet their goals and objectives for providing situational awareness and sound decision making. I think that the efforts, I think, again, as Esty said earlier, I think we've helped make the case for the critical role that open data and public facing data and, GIS can play together within health crises and to help compel an appropriate public response. It's also exposed a lot of things that I think longer term we're going to have to deal with. It's important that we have a decentralized, understanding the balance between a decentralized infrastructure in the U.S., but we also need to figure out a way to deal with the implications of that in this type of pandemic. I think one of the things, and again, Esty alluded to this earlier when she was talking about the need for real-time data, or the expectation for real-time data in health, which is new. One of the big things for us that I think led to adoption of the dashboard is just the public need for data at a spatial and temporal resolution that's actionable, right? If you tell me that there's growing cases in the US, I have no idea what that means for me walking out my door in Maryland and driving to the store, right? But if you tell me at my county level or at my zip code level or at my census tract level, something that's tangible to me that speaks to my environment, I can do something. So with that, I'm going to hand it over to Sean, who's been a huge help to all of these efforts to take you down the further part of that chain. So thank you.
Thanks, Aaron. Let me get my screen set up here real quick. Hope everyone can hear me and the screen's up. Hi, I'm Sean Breyer. I'm the program manager for the Living Atlas at Esri. And what I wanted to do is go through some of the managing and the scaling, the architecture work that went on behind the scenes with the Johns Hopkins dashboard. I'm going to start off with this first slide, which really follows a lot of what Aaron was talking to about, sort of the phases that we were going through as the Johns Hopkins dashboard. One came to life on the 22nd with just Dr. Gardner and Frank quite literally manually scraping off of websites, copying and pasting into a spreadsheet twice a day and trying to build this dashboard. And ends all the way through the automation that Aaron's doing and we were doing along the way as we scaled up. That first day was, like no other day for us. It was a typical, I think it was a Tuesday afternoon. But within a couple of days, we actually noticed that we were getting a lot of activity on Johns Hopkins, and we didn't know what that was related to specifically. So we started poking around, and we found that this dashboard was starting to grow in use. And there was a paper from Lancet that went out from Dr. Gardner and Frank on how they were collecting this information and making it available to all of its users in this dashboard. But as we were reading through that, we were just really curious how they were doing the updates, because the dashboard is a new product. It's been out for about a year and a half. It uses hosted feature services. So it's a fairly new technology with ArcGIS Online, and there's lots of ways you can scale it. And we were noticing lots of usage. So we actually put a call out to them and just asked, hey, how can we help? Looks like you're getting lots of activity. We noticed lots of activity on our servers. Let's see what we can do to optimize this system. So within the first week, we actually worked within my team to build sort of what I would call the stopgap scraper that Aaron mentioned, to give his team time to spin up and stand up a larger resource that we could really manage in this backend pipeline environment. So we very quickly built that so we could replace and add some best practices in. So that this first week was when WHO declared the health emergency, where Italy returns its first cases. The media for the first time showed the dashboard on TV. And within that first week, we were getting over 300 million feature requests a day, with one peak at 750 million, which was by far the highest volume we had seen for a hosted feature service used. So we were learning and scaling in the background at the time. A month into this, we actually had Aaron's team really helping us in the middle point where we were getting things to that GitHub environment, but they were still working very quickly to build this larger pipeline of automation behind the scenes. And that's when things started to get really big in the EU and the Middle East, started reporting issues. And at that point, we were starting to see disaster response teams, not just in the US, but across the world, starting to consume the same service that the dashboard was using. And that generated some interesting problems. And I'll show you some about the architecture and how we used to deal with that. And then as we got through March and April, this is where we brought in the full scraping environment that Aaron was mentioning, but we were also scaling in new ways behind the scenes. And as Aaron was saying, we were switching from one plane to another, but at the same time, our responsibility on the front end of this within the dashboard and the services is we needed to be moving at 100 miles an hour in our car and start changing the tires without actually wrecking everything. So what I wanted to do is sort of go through some of those early day architectures to show you how the environment changed and what we learned and what best practices we were building. So this is really the day one architecture. We mentioned Frank earlier, who was scraping these sites and actually making this Google file and putting it in GitHub. And we were actually pulling up these feature layers and bringing them into the web maps directly. Pretty basic architecture. It was built to get us out the door quickly, but it really wasn't going to scale the way we knew we needed to be able to. So the first thing we did is actually added in some feature capability to do a few things. During the ingestion phase of getting the data from GitHub, we actually created 2 hosted services and put a feature view in front of those. And if you've used our technology a lot, you know the feature view is really just a view of a hosted table. But what most people haven't used before is that view can also switch between layers. So we would actually be loading into one layer while the other one's being used. And then with a few seconds, just do a switch between those two or a flip, just like a live service would be. So there was never a downtime. There was never a need to stop the services and restart them, or a period where all the records would be removed and then replaced with new ones. It would always be current. And this was always done with a CDN, or a content delivery network cache, which would update right after that happened. So it would take a lot of service requests directly off the database server and put them into the cache. And that was what was serving the web maps at that point. And at this point, we were getting about 300 million feature requests a day. We had a peak of around 750 million. The next thing that we saw, and I mentioned this, is the idea that all of a sudden the same service was being used by all these health response groups between these national report centers that were set up to support health modeling and also just local analysis of content. And that generated yet another level of increase in usage. And it was sort of an uncontrolled usage. So in the dashboard, we had sort of managed and optimized everything we were doing in the dashboard around how it worked. So we had already indexed the fields that we would need for the dashboard. We had already sort of optimized the web maps for their best display resolutions and setups. But as the new health community came in with thousands, they had random requests. They could do queries that weren't part of our common cache, and that was sort of creating some instability, or it would fight between their need of the health services group and then the need for this public dashboard. So as we were starting to get more like half a billion a day, we started to see this architecture start to be more and more difficult to maintain stability. So the next step we did was actually duplicate that environment and create a separate thread for the community of those dashboard users, the non-John Hopkins dashboard, and then segregate out the dashboard so it would have a dedicated pipeline separate from the rest of the thing. But these were also always identical. So what the community was seeing was identical to what was on the dashboard, and they were being updated at the same time. You know, as far as best practices here, there was a few things we learned, and Aaron talked to some of those. First was really a strong data and application release practice. We did build in our test QA and production environments in the middle of this as it was all moving, that allowed us to try new things, evaluate changes, look at opportunities to improve performance or actually lessen database overhead during the process. So adding indexes or changing field sizes, all those things were being done in these test environments to make sure everything was good before it got moved to the production, where at the beginning they were just making direct changes to the dashboard as it was being updated, which made it very difficult. If something broke or something changed or something had a big impact on the system, they wouldn't know until it went live. The next was really optimizing and leveraging this content delivery and network for this high availability. So feature services have that CDN capability built into them by default. But to really leverage those, you need to have, you know, sort of a good design, and you have to know what rate. How often should you update your network, your CDN network, that content delivery cache, and clear it? So as we brought the system online, we were actually doing updates every 30 minutes. We would go out and check the GitHub site every 30 minutes to see if there was a change. If there was a change, then we would refresh the CDN network, and that happens just a few minutes after the upload. So there's a cycle of continuously updating as we go. Another thing we really had to really practice closely was keeping a simplified data model. Doing lots of joins when you have billions of people hitting the system is a huge overhead on the server. So we needed to build the data structure in a way that you wouldn't need to do cross-table queries. So when we're doing that, we had to do a lot of design testing on what is the best way. Do we denormalize a data layer? Do we simplify it in a way with a attribute field, or do we actually put in the values? So we were doing that in the background at the same time. And then we really had to spend time reviewing how the data was being used. You know, when we first did it, it was focused completely on the dashboard. What do we need to make the dashboard be performant? And we indexed the appropriate fields that we needed for each one of those subqueries. But then as this additional group of users comes on, there was a whole new set of queries happening. So we had to capture the kind of queries that were happening and then make adjustments and make specific indexes for those. Early on, we actually even had to change the data model of the hosted service. So behind the scenes, you can actually have hosted services that are fed from an ASCII file, a shape file, or a file geodatabase. Initially, that work was actually using a comma-separated file, and that has the advantages of being simple, but it didn't allow you to really create good indexes or control or manage the size of a text field, for example. It would just take the maximum size allowable, which would make it less performant. So we optimized those kind of work going into this. And then we sort of created this, leverage this progressive disclosure. So the dashboard doesn't start out showing you everything you can learn about COVID. There's steps in there, there's separate maps, there's tools that pop up. So by doing that and not trying to put everything on the front dashboard all at once, we were able to get a really responsive dashboard at the beginning. And as you click into each layer, you would get more and more disclosure and detail without a big overhead at the beginning. The other work we had to do was make sure that we got this in a geographic projection that matched the underlying database. So each client wouldn't have to do projection on the fly. And then we had to decide really early, you know, how do we want to share this? So, you know, initially it was the John Hopkins dashboard use case, but as we added this additional use case for everybody else, we had to sort of think through that architecture and make sure that we were meeting the appropriate needs of what they were doing. So, you know, in the end, this actually has created thousands of apps and dashboards, and both on our coronavirus resource hub site, on John Hopkins Resource Center, You continue to see growing numbers of dashboards, either utilizing the content from Johns Hopkins or inspired by their work, or extending it. So even beyond the dashboard everyone's seen for the world, there's a second Johns Hopkins dashboard for the US. And within that US dashboard, you can see things like we're seeing here down in this corner, where we actually have pop-ups for each county that break down resources and availability of hospital beds and the spread of people all through the system. So I think those are all amazing ways that we saw this one hosted service and one set of content explode across the planet. So for me, this was really a chance to say thank you to the Johns Hopkins team and Aaron for putting up and working with us for those 4 months where neither of us really got to sleep very long, to the point where we had a team behind us and working to really build out this platform in a way that it could be used by everyone else in the world. I think what I'll do now is I'm going to hand this over to Tim. So Tim's at Vermont is one of the resources that Aaron uses and goes into the dashboard, but they bring a much more local flavor into understanding how the health services group and GIS really work together. So Tim, I'll hand it over to you.
Okay. Okay, great. I assume you see my screen and can hear me okay. I'm going to keep my video off just so you get a little bit more screen real estate on the slides. And I apologize in advance for trying to cram probably a bit too many slides into too short of a time, but we'll get through it together. So again, my name is Tim Teraway with the state of Vermont, Center for Geographic Information, or VCGI for short. We are part of state government in Vermont. We are not directly in the health department, but might as well be so by now, given how closely we work together. And again, I'd like to just show what it's like from the onset of what we call an official or an authoritative data source from the very beginning, before it gets all the way up to applications like the Johns Hopkins dashboard and the services that go out through the world. So that being said, a little bit about context, echoing Jack Dangermond's talk this morning. The Vermont context, at least until relatively recently, was that we were doing pretty good relative to coronavirus. So you can see in the top right, we had a travel policy implemented depending on the prevalence of the virus or at the county level. And if we applied that across the entire US, it led to very few places being actually able to travel to and from Vermont. But we've been recently experiencing quite a bit of case growth, much akin to what's going on, unfortunately, in uncontrolled spread around the rest of the US in our area. And maybe it's not our dashboarding that's doing so well, but perhaps the context of the culture of Vermont, all 625,000 of us strong. You can find there's even a Reddit channel devoted to social distancing champs in 1791. So we're all up here in the hills hiding out by default. Where CDC, you must be 6 feet apart from each other, awfully close, say the Vermonters. So perhaps it's just in our culture that we tend to take social distancing as more of a norm than perhaps other places. Maybe that's helped as much as our dashboarding efforts. This here is a slightly recent version of the public, what we call the public dashboard. It's embedded on the Vermont Department of Health website. And really it's built on the Esri's Esri's operations dashboard application platform. One of the big things with this is that it's embedded directly in the state of Vermont's Department of Public Health website. It's not a standalone thing that one has to go to a unique URL to find. It's right inside the official website, which only increases the visibility and the authoritative status of the Vermont dashboard itself. And that includes everything like thinking about color psychology, right? Why do we use blue instead of red when we're talking about health matters? So all kinds of details that perhaps one hasn't thought about too much before coming into play with the designing of maps and visualizations around how to communicate current status of this affair across Vermont. And again, if you're looking for the Vermont dashboard itself, it's located at healthvermont.gov/COVID-19 of their current activity in Vermont pages. We also have from the services then and processes that we stand up to populate the public dashboard, we had internal reporting dashboards that have a bit more granularity to them. These are to help leadership at the state of Vermont level make decisions about allocation of resources. But again, these are driven from the same processes that drive the public dashboard. Now, VCGI itself is perhaps a good thing in that it's anomaly. We are, our day jobs are officially about open data, open spatial data services, and in a normal mode, the GIS open data flow looks something like this in the diagram here, where you see there's 255 municipalities, local governments in Vermont with no effective county government. So a lot of cats to herd. And then there's multiple agencies and departments that have differing GIS capacities and needs. We at VCGI normally steward all of the processes along these players and bring them to the public as open data through websites and tools like the Vermont Open Geodata Portal. Now, normally this is a much slower process than in triage mode, where instead of starting over coffee, as Aaron mentioned before with the Johns Hopkins dashboard, as many things today, ours started with a chat in our Teams, Microsoft Teams environment from our chief data officer saying, hey, we need a COVID dashboard. It's updated daily. Outsourcing is tricky. It's expensive. Can you do this? And we at VCGI just sort of said, sure, not knowing what we're getting ourselves into. 250 days later, here we are, including 100 days of working every single day straight. And the beginning of it, here we are maintaining the dashboard to date. So the one thing I want to sort of clarify hopefully today is how exactly does an official COVID-19 data point go from the source to the public every day, whether that's an indicator on cases, on hospitalization, on people tested, or outcomes. The first matter, at least in Vermont, is that a person seeks testing, right? So in Vermont, we're talking about PCR tests are only those that are reported currently, and they're either a positive or a negative test, but it all starts with that person seeking testing. From that, labs, private labs and public labs report their results to the Department of Health in the state of Vermont. And I have a little icon there of not just HL7 messages, but also faxes. Yes, they still have to process faxed information to them on a daily basis. So it all begins with the labs reporting the results of test data. Within the Department of Health, the COVID-19 or SARS-CoV-2 test data itself goes to the database, which is called NBS, of all of their infectious disease information. And that has both a contact tracing team who are regularly in and out to do data quality and updating of that information on the phone with both patients as well as their close contacts. And then you have whole separate teams of data analysis and case management teams that are regularly interacting with this database that makes it difficult to extract reliable, stable data points to drive applications for public reporting purposes, right? So from that, you still have yet more persons who are involved in extracting data from a more dynamic database environment into a singular snapshot file that can be reported and used to build and drive applications. So Vermont Department of Health formats this data daily, reports to federal and state officials. That includes outlets such as the CDC, as well as the governor's office. And of that process, as they're pulling that on a daily basis, a file with a particular schema that drives our public dashboard applications is sent to us at VCGI every morning. And it's an Excel file because it has about 7 tables within it. So as a recap, there's over 80 persons involved at the Vermont Department of Health alone every single day who are going through this whole workflow process on the right-hand side here. Everything from contact tracers who interview patients and update data in the infectious disease database, all the way through, QA, QC, before it even arrives to us at VCGI to work our magic on the application side. So it's quite involved just on the case, tests, outcomes, and geography by day components of public reporting. So that being said, that's behind the scenes of how those particular indicators get to us before we build our applications. Again, these counts are as the previous evening. But again, what's missing? Well, hospitalization, as Aaron mentioned, the nature of mostly fragmented or disparate hospitals across the United States is how they report. The data about persons hospitalized with COVID-19 are sourced elsewhere. And this includes a combination of both manually and automated updates through a variety of private tools that we have gained access to. In Vermont, there's about a little over 15 different providers who are sourcing hospital information through a combination of HL7 messages and manually updating, whether there's someone with suspected virus, for example, that we then pull in a CSV format every single day to augment the case data from the Department of Health. So finally, we're here, we've got our hospitalization data, we've got our case, tests, and geography data, 3 separate files. We at VCGI are finally ready to do what we do with it to drive an application, right? So we have built a 5-step extract, transform, and load process that serves different applications and open data outlets. And from the personnel side of things, that involves myself as a project manager, point of contact, and application open data person, daily operator, and then 3 other folks from a database administrator and an ETL developer and daily operators who keep things running. So there's at any one time, there's a rotating cast of 3 of us any given day who are doing this process to keep the public dashboard reporting going. The first step that we do once we receive these 3 files as formatted is, again, check the schema, because in the very beginning, as you can imagine, the schema was changing all the time. That's not so good for applications that you're trying to drive that demand stable field names, all of that. So we have a process using FME that's built in the data interop expansion that is looking at change detection, looking at the key fields, the way that they're named, and it drives a report and lets us know every time we run an update process whether or not that data has changed or not. So this is the first flag to realize you might have an issue with your data before you proceed any further. Once everything is checked and valid on the schema, things are unchanged, we load that to a staging database environment that allows us to augment and create database views. This is where really the geography components come in. As we're receiving just CSVs and tables, we can do things like join to our county layers. We can create feature layers that have particular filters on them, like 14-day recent cases, et cetera. So a whole bunch of different operations and joins happening during this stage of the SQL staging database that ultimately drive 18 SQL views total, 9 public for the public dashboard and 9 for the internal dashboard, that end up becoming the items that populate hosted feature layers inside of the ArcGIS online environment. Once we have the data inside the staging database and the joins and operations perform such that they're in the format required to drive the end application, we do a last check at pre-publishing on data validation. This is an important part to catch there's any errors that have come through either our process or before that on the epidemiology example. Just yesterday, for example, I had flagged a record in the line list that had a missing age value, which would have made the counts not sum as reported on the public dashboard. So this step caught that, and it let us know at the end of our report, which again is running through data interoperability extension, hosting basically FME, that let us know that that was something to flag before we published, and went back to the point of contact on the EPI side for the day, had the issue resolved, ran the process through to here, and that issue was resolved, and no one ever saw the discrepancy because we caught it during this data validation stage. The 4th step of the 5-step process is one that's actually going on throughout, which is running a set of batch files, basically command line executable scripts that are allowing us to pull from our staging database through the FME environment and all the way eventually up to the ArcGIS Online environment. And this allows us to select which of those hosted feature layers, or basically SQL objects, to publish to ArcGIS Online as we see fit. And the key point with this is that once it goes to this, the data are now live, right? So it's up in ArcGIS Online. Those items are now up to date. So for the public dashboard, for example, we've got 2 feature layers, 6 hosted tables, 4 web naps. Ultimately, what's driving 2 different applications or operations dashboards, both desktop and mobile. We do this because you've probably mentioned, if you try and cram all of this information that normally populates a desktop application into a mobile device, it's not so legible. So we're effectively managing 2 different end applications for increasing the user experience for how it's formatted. This lastly goes to another ArcGIS product, which is Experience Builder, which effectively allows us to do 3 things. It allows us dynamic resizing depending on the native screen resolution of the viewer. So you can see in that animation above how it's dynamically shifting between both desktop and mobile applications. And it also provides a web-based dev prod environment such that if we ever make updates to either of these applications, it maintains a stable URL for the end user. That's really important because institutions such as the COVID tracking project are scraping that URL, and we don't want that to change, right? So Experience Builder allows us that online dev prod environment to make those changes behind the scenes without changing the source URL. And lastly, one of the big parts of updating this information for public use is that we also have an ArcGIS Hub page, which is run straight from our Vermont Open Geodata portal that permits data access to the raw tables or feature layers that are views extracted from the ArcGIS Online object. So anyone can go here and download a CSV, for example, of the daily time series counts as the data as it's published every single day. And again, this is what some institutions like Johns Hopkins COVID tracking project are using to ping and or web scrape to drive, bigger picture applications down the road. So really this is what we do every day. There's, again, probably over 100 people in our little small state who touch a single indicator every single day. And at VCGI, we are happy to be a part of that. Just to wrap up, again, I'll reiterate, the data expectations and demands that have now arguably become normalized are wholly new, both for our little GIS realm, as well as the public health realm, to the point where the pace, detail, domains, and scope of what we call GIS here in quotes, we're everything from, public relations people to web debuggers to, script writers. We're performing all kinds of tasks behind perhaps with a frequency that perhaps we hadn't thought about before, but it was sort of just jumping into the deep end. And then the last thing I'll say is just the larger implications in the context of dashboarding, as much as possible, has brought to our attention at least just how much is required behind the scenes to do this reliably and consistently day in, day out. So with that, I'll thank you very much, and I'll turn it back over to the rest of us. Thank you very much.
Thank you, Tim. And I also want to thank Aaron and Sean for a great set of presentations. I hope you now truly understand what it's been like behind the scenes and what it means for a single dashboard like this to go viral and provide other apps that have also gone viral at the same time. As it turns out, we don't have time for questions, but all of us will be available to answer your questions in the Whova app. So you can still provide them there or chat your comments. We'd love to hear from you. And so I just really want to say thank you. And maybe we can leave with just one thought from each of the panelists. If you can just say over the last 10 months, what has surprised or inspired you the most? So how about if we start with you, Aaron?
Sure, thank you. The most surprising thing to me has been really how much the world has come together to support each other and make this data available. Everybody from folks in public health departments like Tim to open source projects globally that are helping to try and keep everybody informed.
Thank you. Sean, how about you? What surprised or inspired you?
Yeah, I mean, I think the overall breadth and use of the dashboard was really inspiring, but I think also the way that people are now consuming content as a live feed directly from its source rather than making copies of it that they have to manage and update was really a game changer in this. So everyone was seeing the same content at the same time.
Awesome. Tim? You're on mute.
Thank you. That I have a tremendous amount of respect for epidemiologists. And I should say the notion of public service, as we know, the context today is one that's very polarized around government as a whole and public service. And the amount of hours and commitment that people have been doing to public service as an information, as a public resource behind the scenes is just tremendous. And I wish people would recognize that more clearly.
Absolutely. Well, for me, I think it's been the creativity that we've seen from our users, from GIS professionals like you, that I've seen from my own Esri colleagues, the spatial thinking and the spatial approaches to respond to the pandemic have been truly inspiring and amazing. Not so much surprising because I knew we all had it in us, but very inspiring. So thank you so much for attending this session, and we'll see you again sometime soon. Have a great day, everybody.
Thanks, everyone.
Thank you all.
Thank you all.